Hello guys, today we are going to start you the evaluate of the reference concept in CPP programming language, okay? And so we will derive the many examples about how we can use the reference notation in C++ programming language with the function especially for this lesson. But in the first place we should talk about how we can declare or define this concept in CPP, okay? And so as always I can give two command line in here, example 1, and so include iostream file in here like this one, using namespace std in order to what? In order to use this std namespace, and then I can give some return value because of the main has the return type of the integer types, and so I'm pushing the control F5 button in here like this one, and then I can select the C++ language with the G++ executable file in here and so I obtained the .vs code file, okay? Launch and compile task. Okay, so firstly we need to create some examples. For example, if we have the integer value like this one, this x is equal to the what? 5, okay? And so I can easily output this x value like this one, okay? And so if I run this code at the terminal page, we have the x equal 5. Because x is a variable with the type of the integer, so the RAM location we have 4 bytes in order to what? In order to represent the x value with the what? With the initialization value of the 5, okay? And so how can we utilize or define the reference? Firstly, we can select or we can define this kind of code in here, okay? And so we can also use the what? The ref value in here like this one, ref value like this one, and so if I run this code, the two values are the same with the others, okay? And so if I change this value as a 15, and so all the values in the what? In x is equal to 15 and ref is equal to the 15, okay? And so what happened if I change the x value in here? And so after the increment of the x value, if I run this code and print all the values, and so the x is equal to the what? The 16 value, okay? But the ref is the same. So what is the reference? Reference means that and defined by the what? These ampersand operators like this one, okay? If I use these notations, the ref is also an integer value but with the pointer type of these things, okay? Reference includes both the address of variable and its value as well, okay? But the normal variables like the integer x only includes variables include the what? The only the its value, okay? These are the basic difference between the what? The reference concept and the integer value or the normal type of the CPP programming language, okay? And so if I increase the x++ value with the what? With the reference point like this one, and so if I run again this code and then reference is also a 16 value. How we can obtain these counters in here, like this one? Firstly, we need to understand that the x in the first place, like this one, if we are using these things, and so the x and reference value are a different variables on this CPP language, okay? Because the x is equal to the 15, and so this is the right hand side values of the what of this notation or definitions, and so the x is replaced with the what with the 15 from the compiler usage, and so the ref is initialized with the what with the first value of the x in here. But if I use the reference point or reference definition in here, like this one, and so this reference imitates or copy whole of the features of the x, including what? Including the address value of the x and its real value in the type of the integers, okay? This is what? This is the definition of the reference concept. And so if we have this kind of definition in here, like this one, and so if we are increasing the x plus plus, or as is x is equal to the what is equal to the 16 right now, and so this reference value is also increased because the reference is not different with the x. The reference is replaced with the x, including both the address value of this variable and its values, okay? This is the basic difference between the what? Normal type of the C integer, double, or the char character in the C++ programming language and or with the reference concepts, okay? And so if you have this notation in here, like this one, if we have the reference equal to the 1, okay? What will happen if I'm running this code? And so if I'm pushing the Ctrl F5 button in here, like this one, and so the both x and reference value is equalized to the what? To the 1 value, okay? Because the reference is the same with the x value, and so as or reference is updated or assigned to some variables, and so x is also assigned to some variables. But in the not usage of the reference concept in here, there are no difference between the x value while updating the reference, okay? And so the reference concepts can be defined by using the what? By using the address value of and its normal value or constant value of any variable, okay? We can easily replace the x with the ref or ref with the x. This is the first example of our session in here, like this one, and so we can add another example in here as an example 2, okay? And so in the previous lesson we have talked about the swap notation. As you remember, we can give the swap function in here, like this one, integer reference first, integer reference second in here, like this one. We can define the temp value in here first equal to the second, and second should be assigned to the temps, okay? And so if I'm giving the x2 y6 in here, and at the end of the swap operation in here, like this one, xy, we can see out the both values x y can be assigned at the at the end of this code. Okay, and so if I'm run this code, and so x is assigned to 6, y is assigned to 2, because we can give both the address value and its normal value to to this swap function. Okay, and so if I'm removing the ampersand operator in here like this one, and so this code gives us to 6, even if we call the swap function. That's wrong. But if I'm using this notation in here like this one, and so we can swap these values. First thing is important in here, because this x and y value are the local variable. Local variable means that it's only current in in this region or in this parentheses. Okay, and so if I'm defining this value, and so if you have this information, and so if we want to transmit whole the information, its values, into another place or another function, we should use either pointers or the reference value. Reference value cannot be included in the C programming language. It's the addition to the CPP programming language, and so it's much safer than the pointers. But the pointers has many options to manipulate your codes in order to reach some address points. But if you are using the reference concepts like this one, we don't have the many errors in your codes, okay, or less errors. This is the basic difference of this thing, but the reference concept is a highly complicated parameters in here like this one. And so if we have this example in here like this one, and then we should give some specific examples in here. Firstly, we should debate the reference concepts. Int x equal to 5, okay, and so int reference ref1 is equal to the x, int reference ref2 is equal to the x, int reference ref3 is equal to the x. Okay, and so cout value x and lee, and so I can copy off all of these things in here like this one: ref1, ref2, ref3, ref1, 2, 3. And so if I'm running this code, and so the ref1, ref2 and ref3 is also assigned to the 5, and so the variables can be defined or indicated by more than one reference notation. Okay, and so what happens? Ref1 is increased in here, and then the hold values is increased. Okay, ref2 increased, and so ref3 decreased and x decrease. If I'm using these notations in here at the end of this code, x or ref1, ref2 and ref3 is equalized to the to the 5 value. Okay, this is the third example of this session, and so we can easily say that the variables, any variables that defined in the CPP programming language can be indicated by the more than one reference notation or reference values. How can we use this information in the real life applications? For example, we can design the controller in the car or airplane, and so everyone or every components can call or can use the motor speeds. Okay, but the cockpit or the airplane heading motion uses these values as a thruster or the force diagrams, and so we can set the new name in here like this one: integer, reference, thrust, motor speed. Okay, or we can use this, the longitudinal motion speed. Okay, at the same time these two values are the same, but we have the many microprocessors or the processors on the on the airplane or the car or the computers. Okay, and so even if this value is the same with the with the measured value, in the first place, or the thrust motor speeds can control the motor speeds. Okay, and so we can easily set this name by using these reference concepts in order to easily understand what we are writing in that code. Okay, and so many include files or many source file can be used in the design of the controller of the car or airplane, and so we should name, or we should give some specific names in order to same variables or represent the same variables. But if we are using the whole components this x, it's meaningless. But if we are using this thrust motor speeds or longitudinal motion speeds, more meaningful to process whole the information coming from the x. But in the real application, x is the same. This thrust motor speeds or the longitudinal motion speeds is the same. Okay, but in that situations we can easily indicate what we are using or what we are going to have or need it to be in order to design your controller. Okay, and so this is the third example of our session. We can copy all of these things in here like this one. Okay, it's the example 4. Okay, what happens if we rotate the ref1 and ref2 variable in here? If we can use this x value with a reference point in here like this one, and so the reference must be referenced in the CPP programming language. Okay, and so I'm deleting the executable file in here, and then if I'm run this code, all the values is equal to is equal to 5, but ref3 is increased in here like this one, and so all the values is updated. And then we can conclude that the reference values could be referenced, could be taken as reference as value. Okay, this is how we can use the reference value in here like this one. Okay, and so this is the fourth example in our notation in here. Okay, this is the fifth or 5th example at this moment. Okay, and so we need to evaluate the function reference concepts right now. Okay, firstly I'm giving the integer func value in here like this one. Okay, integer x value is equal to the 10 and return the x value in here. Okay, and so we can call the func value in here like this one: func value func, and so if I'm run this code, the func value returns to what? Returns to 10. Okay, what happened if we are using these notations in here? In the first place, the func value is return type to the what? To the x value in here. But the compiler tells us the expression must be a modifiable L value. What is the L value and right value or R value? Left value is that we can combine the whole information in order to what? In order to storage to these kind of values. And so as a consequence, we can use the L value in order to what? In order to manipulate its value or address value with the what? With the increments, division, or the some basic multiplication or mathematical operations can be obtainable or can be performed or on these L value notations. But the 5 otherwise is a right value or R value. What's the meaning of the R value? R value, you can think that the R value is always a constant value. Okay, the 5 cannot be changed in the whatever we are using the compile time or the runtime operations. Is a constant or literal value. Okay, we cannot manipulate the 5 values or any other const value in this notation, and so we can call it the R value. Okay, right hand side value. Okay, but if you are set this func with the return type of the what? The reference value. If we are using these notations and then if I'm running this code, the func is giving the what? The exception has occurred in here. Okay, but what's the error of this function? The compiler tells us the int x, the reference to local variable, is returned in here. What does that mean? You are using the int reference value in here, but the x is not a reference value. Okay, if we have this kind of information, we can use the reference in here like this one. Okay, and then the error is gone or missing right now. If I'm run this code again, and so we have the problem, cannot bind the non-const L value reference of type int reference to the int. Okay, okay, we cannot represent the what? The 10 or right value into the what? The reference, because the 10 has no address point on this compiler notation or the RAM locations. We should always use the what? Use these things. Int y is equal to the 10. Okay, and so y should be equalized these things, and so if I'm run this code and then the func value is equal to the 10, but there is no syntax error. These are the awkward parts of this CPP programming language. But if I'm change this notation in here like this one, and so the executable file should be deleted in here in order to recompile of your code, and then we cannot compile this code because the L value required as a left operand of assignment. But if I'm adding to this notation in here like this one, the func value is always 10. Okay, how can we use this specific notation in here? If we are using this code, this is the what we can comment of this line. If we are using the non-static or non-local variable like this one, static int x value is equal to the 10. And so if we have this kind of representation in here, we can return the x value in here. After that, if we are using this code in here, the func value is normally equal to 5. These are the interesting points of the usage of the reference usage. In what? In CPP programming language. If the x value is not a static variable or non-local variable like the static definitions, and so we can return this x value with the reference point, and so this as x is created in here like this one, and so this func value can be assigned to the what? To the 5. But in the background, this func values represents only the x value in here. For example, if we have this kind of information in here, and so this is equal to the what? Equal to the assigned these things. Okay? And so if I'm run this code, and then the x was not declared in these scopes. But if I'm using the func function, because the func is seen on this page, and so if I'm running this code, and then func is assigned to the 5. Okay, if we have this kind of information in here, we can also call this func notation like this one: func times func. And so if we have this information, and so func value is equal to the 25. It's the interesting point of the usage of these notations or the reference concepts, or we can assign to the minus func body in here. But the compiler sees this definition in here like this one: x is equal to the x times x minus x. Okay, but in the usage of these things, the func or this function definition is only represents the x value at this moment. Okay, this is how we can use the reference points on the CPP programming language. And then we will move to some advanced example in here with the usage of the function notation. Okay, and so we can delete all this information in here, and then we can build a new example. Okay, and so firstly we need to add the int reference x value in here, and we can return the x value. Okay, yeah. What happens if we call this function like this one? Okay, and so the x value in here like this one. Okay, if I'm run this code, and so the func value is equal to the 20, but the previous executable file is in here, and if I'm run this code, this file gives us to the 10 value as an error, because we have the reference point in here, and we can return the int reference value. Okay, and then if we say that this 10 value in here like this one is assigned to the to this value, and so the compiler tell us to the int reference x cannot be equalized or initialized with the what? With the 10 value in here, because this is literal or constant value or r value in here. But the definition of these things is okay. And so how can we overcome for this error? If we have integer x value in here or a value like 5, okay, integer reference or a value can be assigned at this moment. If we have this usage in here like this one, and so the x return to the what? To 5 value, but we cannot assign to the what? To the 10 value in here, because it's the same with the what in the x reference equal to the 10. Okay, this gives an error because the 10 cannot be manipulated by the compilers because it's a constant value, and so the reference cannot be equalized to the what? To the 10. Okay, and so how can we redefine this a variable in here? Firstly, I can show you a value is equal to the what? To the a endly. Okay, if I'm run this code, the x and a value is equal to the what? Is equal to the 5. But what happens if we multiply the x times x in here like this one, or this x plus 5 in here? If I'm run this code, and so the main executable file should be deleted in here, and then we have syntax error. Initial value of reference to non-const must be an L value in here. Okay, which means that the x cannot be increased or decreased in here. But what happens if you are using this notation in here? If I'm run this code, and also we have the what? The L value reference in here. Okay. We can say that we can return this x value in here with what? With the usage of this notation in here like this one, and so there is no syntax error in here, but we cannot increase this x value in here. But what happens if we initialize the int y value in here, or int reference y value in here? And so y plus plus can be added in here, and y is increased at this moment. And so if I'm using this notation, voila, the x value is increased to the what? To the 6, because the int reference value is assigned to the what? The x, and y is increased and return y with the definition of int reference value, and so this func returns to the x or 6 value. But also a value in here is what? Is 6 value or 6, because this a, this x, this y are using the same general notation or general location on the what? RAM storage, because the reference points both includes the what? Address and its normal value. Okay, and so what happens if we are using the int reference z value is equal to the a, and so z or z plus plus at this moment? If I'm using this notation in here like this one, the both x and 7, x and a value is updated. Okay, And so what happens if we are using this notation in here, like this one? And x gives us to what? The -1 value. But the func a is what? Is given other value. Okay? Firstly, we need to understand that the z is equal to the what? Is equal to a value. And so at this point, this equalizes to the what? This equalizes to the 6 value. But after the func operation, this z should be updated because if I'm using this normal z and value is written on this page, the x value is equal to the what? Or z minus func a value is equal to the what? The -1. A value 7, z value is 7. Okay? But the z or a or y or x are the same variable in here. What happens in this code? In this code, the func a variable is updated. Okay? Is updated in here like this one. And so this return y value is equalized to what? The 7. But in the first place, if we have this subtract operation, or if we have the same line operation in here like this one, the z value is not increased at this moment. Okay? Because the func a is updated right now, but the z is not, even if the z or a are the same variable. You should remember that. Okay? Because in the otherwise, the z and a value is equal to the what? Is equal to the other things, and so this gives us a 0. Okay? Because the int reference return type in here and y should be equalized to what? The a. What happens right now if you have this kind of notation? There are no difference in that moment. Okay? Or what happens if we change this a minus func z notation in here? Is also gives us the -1 1. What happened? A plus plus should be added in here like this one. If we have this kind of information, and also a give to -1, but the a or z value is equal to the what? The 8. Okay? Or y value is equal to the what? And li is equal to the what? The -1. Okay? And li and d. Okay? And so if we have this information in here, the y is equal to the what? Is equal to the same a value, 8, and so func z value is equal to the 7, and so it gives us the -1. Okay? But what happens if we are using this notation in here? -2. So this relates to the what? It's related to priority level of the what? Of the code running on CPP programming language. Okay? If you have this kind of information in here like this one, and so the reference can be returned to the what? To the different values, even if the z, a, y or x value are the same. Okay? This is the exceptional point on what we are using, the what or how we are using the reference notation on CPP programming language. Okay? And so this is the last example relates to what the reference notation or reference concept on CPP programming language. you should iterate your knowledge by using this, solving the many examples about how we can use the reference concept on CPP programming language instead of the pointers. You don't know the pointers knowledge in here right now, but don't worry, you should only focus on the reference concept on CPP programming language. Okay, see you guys.